This work comes out of a ESRC project that actually involves Hill as a co-investigator. That will be coming to its end next year. And this particular work is joint with my colleagues at Bristol in the Centre for Multi-Level Modelling, and yes, it's a longitudinal analysis of residential location choice. And I haven't presented this work to geographers before, and I imagine that most of you are geographers, so I'm particularly interested in your take on the approach and how it could be extended. This is very much still a work in progress. Okay, so a quick outline of my talk. I'll start off just by giving you an overview of what motivates us to do this work, an even quicker overview of previous approaches to the problem, and then just to fix ideas, I want to define what we mean by a neighbourhood, how we measure that in our application, and also what we mean when we're talking about a set of neighbourhoods that a person can choose between when they're moving. How do we define this set? Because it does have to be restricted in some way. I'll then talk about the most commonly applied version of the method that I'll talk about, and that really applies only to cross-sectional data. So we're going to be looking at extending that to longitudinal data, where we're using panel data, and by using the longitudinal data, that allows us to differentiate between push and pull effects. So, and I'll define that in a moment. Now, there are some practical issues in implementing these methods to do with having a very large set of potential areas that a person could move to at any point in time. So I'll talk through how we handle that issue, and I'll talk about an application to the British Household Panel Survey. And we're going to be focusing only on one area characteristic. The approach can be extended to include several at the same time. But I think, as you see when we get to the results, there's quite a lot to talk about with only one characteristic. And our focus is going to be on how area deprivation, how the effect of area deprivation on area choice depends on individual characteristics. That's what I mean by differential effects. And if I have time, I'd like to just talk about one assumption that's made in the method that I'm going to talk about. It's called the independence of irrelevant alternatives, and much discussion of that in the economics literature. And if I have time, I'll talk about how we extend the model to relax that assumption. All right. So, a little bit of motivation. I think the first statement there is probably uncontroversial to a group of geographers. So a great deal of interest in looking at area effects in various individual outcomes. But then there's concern about biases that can arise in estimating these effects because of the way that people select into different types of neighbourhood. Okay? So the objective of our research is to really try to understand better how people choose the neighbourhood that they live in. And we distinguish between the effects of neighbourhood characteristics on a person's chance of moving out of an area, that's what we call push effects, from the effects of neighbourhood characteristics on a person's chance of moving into a particular area. So, are they attracted by the characteristics of a new area? And as I mentioned, we expect that these push and pull effects will differ according to individual characteristics, and with longitudinal data, of course, we've got information on how those individual characteristics change over time. So we're also interested in how transitions that occur to an individual can influence the extent to which area deprivation motivates a move out of an area or into an area. So, for example, you might expect that the effect of deprivation would be very different for a single person to parents with children. Now, I should say right at the start here, I've been talking about choice, and the word choice gets used a lot when discussing these models, but of course it's very important to recognise that people don't always live where they choose to live. What we're not modelling here is preferences. That's what we would like to, but of course those preferences are constrained by various factors. Okay. So if you think, when I talk about the word choice, think of it as a shorthand, but it really is combining both preferences and the extent to which those preferences are constrained. by individual circumstances. Okay. But that's something to consider when we interpret the results. I think that comes out quite strongly in some cases, that what we're really capturing is more an effect of constraints rather than underlying preferences. Okay, so the aims of our research, and they're both methodological and more substantive. So methodologically, we want to develop a method that will allow us to make this distinction between push and pull effects, and also to allow, moving on to the differential push and pull effect, allowing a person's sensitivity to different area characteristics to depend on their own characteristics. And those characteristics could be observed, and we can include them in our analysis as covariates, but they could also be unobserved. And that's what I get onto at the very end of the talk. Well, we'll see if we have time there. But what we do to allow for unobserved effects is to essentially allow random effects at the individual level. As you'll see as the talk goes on, we end up with a very large analysis file. So there are a lot of computational issues in estimating these models when we move on to allow for random effects. Not so much when you're just allowing for observed covariates, but it's still an issue that needs to be thought about. And so one of our objectives is to implement these methods in software that will be free for people to use at the end of the project. And that's being developed under another ESRC project, which is a node of the National Centre for Research Methods that you might be familiar with. So that will be another objective for the work. And then finally, I'll be illustrating this method and this effect of area deprivation in England. Okay, so a brief overview now of how people have looked at residential choice in previous work. First of all, I should say there has been work that does attempt to elicit underlying preferences. Okay, so what that work tends to do is it will present respondents with a range of different areas, different types of area with different descriptions, and then a person will be asked, which area would you prefer to live in? And then there will be interest in how the choice interacts with the person's own characteristics. So that's been used a lot to look at racial segregation, particularly in the US. All right, so to what extent do people of a particular ethnic group choose to live in an area as defined by the proportion of a different ethnic group in that area. So but in our work, and in common with a lot of the other approaches, we're focusing on observed locations rather than these preferences, just recognising that there's not going to be an accurate reflection necessarily of preferences. So this work that I'm reviewing here is looking at the observed locations. So I'll start off by talking about what I call two-stage approaches. And the first stage involves modelling the residential mobility process. In other words, just modelling if and when people move house. Okay. And in that model, you can include, as covariates, characteristics of their current area. So this sort of approach allows you to get at push effects. Okay. To what extent does living in a deprived area encourage me to move to a different area? And the second stage, and often these two stages will not be done in the same piece of work, but the second stage is to focus on those who've moved recently, and then to compare the area that they moved to with the area that they moved from. And that comparison will be used to define a dependent variable. So it could be, say, the difference in some measure of neighbourhood quality between the origin and the destination area. Or, as I've mentioned, that US literature, they look at, say, the proportion of a particular ethnic group in their destination area. Now, the limitation with that approach is that you can only consider one dimension of neighbourhood quality at a time, because that's defining your dependent variable. So moving on to the other sort of group of approaches, they use discrete choice models, and that's what I'm going to be using. But they really focus on a cross-section. And the idea here is that a person at a particular point in time will choose between a number of potential areas that they could move to. And this analysis is not restricted to those who've moved recently, and it can consider multiple area characteristics. These are all entered as covariates. So these areas have covariates attached to them. But if you're looking at things cross-sectionally, you cannot then disentangle these push and pull effects. So we're extending these cross-sectional models to look at longitudinal data. So we're developing a longitudinal discrete choice model. So the idea here is that every year we've got annual panel data. A household decides where they want to live. They can stay in their current area or they can move to a new area. And that choice will depend on characteristics of these potential destinations, where those potential destinations include their current area. Okay? For example, deprivation, that's our focus today. And then you can allow the effects of these area characteristics to depend upon individual household characteristics. So that's what we're going to do in a nutshell. We're just going to give you a few more details now as to how we actually implement this in practice. Well, first of all, let me just tell you how we define area. What is a neighbourhood? Well, we take a neighbourhood as a lower super output area from the 2001 census. So we've got just over 32,000 of those in England. Additionally, what we do is we restrict the choice set. Of course, a person could move at any point in time, they could move anywhere in the whole of England, well, or beyond. Okay? So you could imagine a situation, if you were only focusing on moves within England, of a choice set which contains 32,500 alternatives. Okay? That turns out not to be practical. So what we do is we restrict the choice set to areas within a labour market area, defined as a travel to work area. And I mean, as you'll know as geographers, these are commuting areas. And the idea here then is that we're focusing mainly on moves that are not employment related, because a person could move within the same travel to work area and keep the same job. All right? So the type of moves that we're really focusing here are moves to change the size of the dwelling, or moves to another neighbourhood, say to move to a better school. All right, those are the sorts of moves. And they account for a large number of moves, 70%. We also allow for moves just around the boundaries as well, so we're not applying this very strict cut-off, and that then accounts for about 80% of moves. Okay. But it's quite common in this literature to distinguish between long and short distance moves, because they do have quite different factors influencing them. So we're focusing on the shorter distance ones. Alright, so a little information now on the statistical model. So I'm starting off with the cross-sectional model, and at the moment, yes, we're including these area characteristics, just one area characteristic and one individual characteristic. So we've essentially just got a multinomial, a nominal variable, which identifies which area a person is living in at a particular point in time. Okay? And then we can model the probability that they're in one of those areas. That's our PRI. And that expression there for the probability, that's if you're familiar with multinomial logistic regression, it looks very much like that. But, I haven't got a pointer, but you can see there, you can see the mouse. This is the linear predictor, the part that goes in there. And if you're familiar with multinomial logistic regression, this looks a bit different, because the coefficients are fixed across the alternatives, but the covariates can vary across them. Okay? So we've got characteristics that are relating to the different alternatives. And then they are interacted with individual characteristics. So that's allowing the effect of an area characteristic to depend on a person's individual characteristics. And these models are very often referred to in the literature as conditional logit models, although conditional logit is really referring to the method of estimation. But they're just a type of multinomial logistic regression. And you can combine the two. So I could, if I wanted, have coefficients that also vary across the alternatives. But because here we've got a very large number of alternatives, that generally isn't of interest, or it's certainly not practically feasible anyway. Okay, so that's the sort of discrete choice model for a cross-section that we're going to be extending. Okay, well, limitations of a cross-sectional model. Well, of course, we know that a person could have been resident in the area that we observe for a very long time. There's a lot of inertia in the housing market for various reasons. And of course, where a person lives then may reflect characteristics of the area that were relevant at the time that they moved there. It could also reflect characteristics of the individual that were relevant when they moved there. Okay? And a person's preferences and also their circumstances will change over time. So we're not picking that up just by looking at the cross-section and relating that to the individual's characteristics at that point in time. So you really need the longitudinal data to allow for this separation of effects of characteristics on the decision to stay in an area versus the decision to move to a new area, this push and pull idea. Okay, so let me now move on to the longitudinal model. So we now have a subscript t, which is indicating time. So between 2 years, say, 2 points in time, t minus 1 and t, a person is making a choice between areas in their choice set. In our case, the travel to work area that they were living in at t minus 1. And again, we have this categorical response variable indicating where they are actually living at time t. Now, in the literature, the only work that we're aware of that's considered a longitudinal approach is a really comprehensive review that's appeared just last year in Sociological Methodology. It's really worth a look if you're at all interested in residential mobility. They also consider modelling the preference data that I mentioned at the start. But what they do is they just include an indicator of whether a person was already resident in a particular area at the previous time point. I'll call that W. And they include that model just as a covariate. And what that allows for is this sort of inertia in the housing. Most people stay where they are. Okay, so it's just allowing for the fact that by and large, people will be in the same area at t as they were at t minus 1. Okay. But then looking at that approach, I thought there's actually a lot more potential with this simple indicator W. And using this indicator and longitudinal data, you could actually try to separate out these push and pull effects. So what we do is we extend this Bruck-and-Mayer approach to estimate these push and pull effects, to allow these push and pull effects to depend on covariates, and then at the end, if I have time, to allow for what we call unobserved heterogeneity, so unobserved individual characteristics that could also influence the effect of neighbourhood characteristics. Okay, so what does this model look like? And to simplify things, for the moment I've excluded individual characteristics. So this model only depends on two things. It depends on this W indicator of where they were resident at the previous time point, and also an area characteristic Z. And that area characteristic can change over time. And it relates to, everything is lagged, so it relates to t minus 1 because we're looking at the choice, if you like, between t minus 1 and t. Okay. And this sort of the linear predictor of the model is essentially partitioned into two components. So this part gets switched on if a person was resident already in area R, and this part gets switched on if they were not resident in R. Okay, so you can't have both of these at the same time. W can only be 1 or 0. And it's easier to understand how this model gives us push and pull effects if we write it down in this form. We write it down in the form of the log of a ratio of probabilities. Probability of being in an area S versus being in an area R, all at time t. And that is just the difference between this expression here for R and S and R. And what I'm going to do now, just to show you how we derive these push and pull effects, is to consider two different cases. The first is a case where an individual is not resident in either of these two areas that we're comparing, so they're both potential areas. And the second case is when they're resident in one of the areas, let's say it's area R. And we're going to see what that expression looks like for each of these two cases. So I've just written at the top there this general expression. We're just going to be substituting in different values of W into that. So the first scenario, that's when a person is not resident in either area at t minus 1. So then this log of the ratio of probabilities only involves this second part here, because this will be 0 in both cases. Okay. So now if we look at the coefficient then, gamma of z, we can interpret that as the effect of the difference in z between two potential areas, S and R, okay, where neither of those areas are the current residents. So we interpret that as a pull factor. Okay, to what extent does Z pull a person to area S rather than area R? Okay, now we consider the second case. So this is when a person is resident in R at t minus 1, so one of the areas. And in this case, then, this will get switched on for R. And we end up with this expression here. So this has got three parameters. Gamma comes in again, and again that's a pull effect. So if I skip to the bottom, that gamma is a coefficient of Z, which F for area S, which is a potential area, not the area they're currently in. So we call that a pull effect. Whereas beta, that's a push effect because it's the coefficient of the characteristic of the area that they're currently resident in, ZR. And then the final parameter, alpha, that's just the, if you like, the main effect of W, and that's just allowing for this inertia. Okay, the fact that most people remain where they are, and you would expect alpha to be greater than 0. Okay, and then just to see how this works for our application. So we're looking at area deprivation, that's our Z, where a higher value of Z indicates higher deprivation. So I've just written down there the two expressions for our two scenarios. So the first one is resident in neither, and the second one is resident in one of the areas, area R. Okay, so let's look at the let's look at the second expression first of all, and we've got this coefficient beta. Now, if minus beta is greater than 0, that implies that an increase in Z in the current area is associated with an increase in the probability of moving out of that area. Okay? In other words, an increase in the probability of being in S rather than area R at time t. Right? So this minus beta is what we call the push effect. Whereas gamma, because higher deprivation is indicated by higher values of Z, we would expect that to be less than 0. In other words, higher deprivation in a potential area would decrease the probability of that area being chosen versus remaining in the current area R. Okay? So what I'm going to be showing when we get onto the application are estimates of the minus beta, which we expect to be greater than 0, and gamma, which we expect to be less than 0. Okay, and then the differential push and pull effect. This is where we introduce the individual characteristics, and let me just skip to this part here. You see now the push and the pull effect are depending on X, and we're going to be considering a range of individual characteristics that takes the place of X. So this model is essentially fitted by including interactions between X and Z and interacting also with W, or with 1 minus W. So this model is essentially it's got a set of interaction effects to capture these push and pull effects and differential effects. Alright, now I mentioned at the start that you can end up with a very large analysis file. This is why. Now, to keep this reasonable for presentation, I've considered an oddie example where we've got just 2 waves that a person is observed at, and only 4 areas to choose from. So the key point here is that for each wave that a person is observed at, they have 4 records, 1 for each potential area, okay, including the area that they're currently living in. And from that, we then construct a binary indicator, that's my choice variable at the end there, which is indicating which area they're currently living in, which of the 4. All right, so only one of them can be 1, all the rest will be 0. Okay. And that is essentially, that binary variable there is my outcome variable. And then the conditional logit method of estimation essentially recognises that all the records for the same wave and individual go together. So they're not all being treated as independent. It's correctly recognising the structure of the data. But you have to get the data into this structure before you can proceed with the analysis. Okay, so that's 4 areas. So imagine if I considered a move anywhere in England, I would have over 32,000 records for every person wave. Right, so not really feasible. So that's why we restrict the choice set to travel to work areas. So that's one of the reasons. We have to do something a bit further as well, but that's the main reason for the restriction. Okay. And if you look at the literature where they've applied these models cross-sectionally, they tend to be focused on a fairly small district, and then they will look at moves around neighbourhoods within that district. There's quite a lot of work in the US. Okay, so they try and contain the problem that way. Okay, we also do some sampling, and this turns out to work very well. So one way of handling the choice set is to restrict the choice set to the travel to work area. The other approach that we do is to sample areas. So in other words, here I've got 4 records per individual. I take a sample of the records for each person wave. And the selection probability then enters the model. It says an offset term. Essentially it's just a covariate with a coefficient forced to be 1. And that works very well. And if you go back to the original work using these models, it was mentioned there. It does come from quite a strong assumption made by the model, but it works very well. And you can have differential selection probabilities, which we take advantage of. So in large metropolitan areas like London, if you remember, we have over 5,000 small areas. So even then you're going to have 5,000 records for every person wave for a Londoner. So again, it's not feasible. So we take a smaller sampling fraction in London to other areas. Okay, but we just allow for that then in the model. Now when you move on to include the random effects, the theory doesn't follow through, but there has been some simulation work recently that gives us some optimism that this also works. And we've also been doing some sensitivity analysis, and it does seem to work fairly well. In other words, what we do is we consider different sampling fractions and see how sensitive our results are to that. And they are fairly consistent. Okay. All right. So, moving on to the application, the measure of area deprivation that we use. So one of our reasons for focusing on the lower super output area was so that we could use indices of multiple deprivation. And in this early phase of the work, we're using the single composite measure of deprivation. But as you'll know, there are measures in several domains that we could have used and that we would like to look at in the future. Now there is some time varying information on this measure, which we incorporate into our analysis, although there's a high degree of autocorrelation in these measures. Because the measures only go back as far as 1999, we restrict our analysis to residential location from 1999 onwards, up to 2008, which is what we have the data available for at the time that we started this work. And the measure that we use has been standardised, so it has a mean of 0, and it's standardised on the distribution in 2007. So just bear in mind that a unit is a standard deviation. Okay, and in terms of individual level data, this is our individual characteristics that we include. Well, we're using data from the BHPS. We're focusing on individuals of employment age. We need to know what area they were living, both in T-1 and T, just in order to define our outcome variable, and also that essential W indicator. Now, an important issue to consider when you're analysing BHPS, I've sort of used individual and household interchangeably throughout, and there was a good reason for that. In other work that we've done, what we do is, when you've got a couple, we treat that as a single decision-making unit. So while a couple is still together, we treat them as just as one unit. But if the couple splits up, then they become 2 independent decision-making units. And all other individuals are treated as if they were separate households. Okay, we only have adults though. Right. So that comes from previous work that we've done that's tried to look at this issue of the household changing composition over time. How do you allow for that in the analysis? So we've taken this fairly simple approach. All right. Now, if we hadn't restricted this is if we have restricted the choice set to travel to work areas, but we haven't done any sampling. We end up with 29 million records. Right? So they're not feasible. So what we do is we do this sampling. I can't remember what the sampling fraction was, but it doesn't make a great deal of difference. And so by doing this, we end up with around 830,000 records, which is feasible. Okay, now this is in terms of the individual characteristics, what I call sources of differential push and pull effects. So a range of characteristics that we consider there. So we've got annual income, they're all lagged, T-1, housing tenure, household type. We're also allowing for the deprivation of the neighbourhood that the person is living in at T-1, because you might expect that the deprivation of the potential area may depend on the deprivation of where they're actually living. Okay, perhaps people already living in deprived areas may be less averse to moving to a deprived area. That was the idea there. We've got some indicators of transitions that have occurred to the person between T-1 and T, so partnership transitions, but they didn't turn out to be important. So the ones that we consider are whether there's been a birth, and also whether there's been a change in tenure, and in particular whether a person has moved into home ownership. And we explore whether effects are different for London and for the rest of England. Okay, now I'm just going to now present to you a number of results, and I think that's probably as far as we'll get. I'm going to show them in two forms. Now, the traditional way, of course, of displaying results is to show you the coefficients estimated from the model. And I'm going to be showing you these push and pull coefficients, and then showing you how those effects change with different individual or household characteristics. And they give you effects, as you know, in any regression model, their effects holding constant the values of the other characteristics. But of course, we know that a lot of those characteristics are going to be highly correlated. So a person who is a social tenant is also going to have a low income, and they're probably going to already be living in a deprived area. Okay, so a lot of these characteristics go together. So as a kind of supplement to the coefficients, we've also estimated for every individual their push and pull effects, their individual push and pull effects of deprivation, and they will depend on their own characteristics, their tenure, their income, and so on, all the covariates that we consider in the model. And the idea there is that you may have some characteristics that, say, increase a person's sensitivity to deprivation, for example, having a child, new birth, whereas there could be other characteristics that that person has that decreases their sensitivity. So the two then could balance each other out. So that's why we consider also looking at these individual effects, and what we do then is summarise these across different groups, just to get an idea of what a typical push and pull effect would be for an individual in a group, given their other characteristics, their other observed characteristics. Okay. I'm going to show you the results separately for each X, but just bear in mind the estimates all come from one single model. I'll highlight differences where they exist between London and the rest of England, and also just to say that at the moment these results are not from random effects models, but they do adjust the standard errors are adjusted for clustering by individual, okay, because of the longitudinal nature of the data. And I'm not going to have time, but if you want to look at the slides afterwards, you'll see some results from the random effects models later. So these models can all be estimated in stata. And although it's a very large data set, it's only a matter of minutes to estimate that model. When we move on to the random effects, we've spent a lot of time, my co-authors Chris and Bill have, in trying to make this more efficient. The first time we estimated the model took about 15 days. And that was, we started off using, I don't know if you've used the WinBug software before, and that just collapsed. So there's no hope of fitting it in that. So 15 days, but now it's down to 8 hours. So that seems very fast. If you compare it to what it was, if I said to you 8 hours, you think, oh, that's an awful long time. But if I compare it to what it was, You'll see it's quite an improvement. But that's what you can do. If you can write custom code, then you can speed it up by quite a lot. And if you've got a software engineer who happens to work with you. Okay, so let me just then go on to present some results. So, what I've started with here are what I call overall effects of deprivation, the push and the pull effects. And if you remember, I said that I expected the push effect to be positive, this is the minus beta, and the pull effect to be negative, and it is. And these are the effects for people in the reference categories of all of the other variables. So, childless couple, homeowner, and so on. Right. So, just moving to the bottom there, what that tells us then is the effect of a 1 standard deviation increase in deprivation is to increase a person's probability of moving out of that area, whereas it decreases a person's chance of moving to an area, right. The area with high deprivation. Okay. And that's the coefficients, and then the second presentation of results, that comes from these individual push and pull effects that are taking into account the mix of characteristics that people have, and the high correlation between them. So the 30,915, that's the total number of person waves in the data file. So all we do is we take the average of those across all individuals, and the results are fairly in line with what you see from the coefficients. Okay? And the standard deviation is just the standard deviation, these individual effects across the whole sample. Okay? So now I'm just going to show you these two sets of results for different characteristics X, and I won't show you all of them. I'll skip through a few, but let me first of all show you income. So I'm starting off here with the push effects of household income, and we have at the top left-hand side we've got the coefficients. So on the top here we've got the push effect that we've just seen. That's for the reference category, and the reference category includes somebody whose income is at the mean. And then what we've got is if you like, the additional push effect for each each unit increase in income. First of all for rest of England, and then secondly for London. Okay, so in London only, we see that this sort of strengthening aversion to deprivation the higher a person's income is. Okay, so if you like, well-off Londoners can afford to move out of the deprived area. Okay, and that tendency increases with their income. Okay, but outside London we have no significant effect of income, so this aversion to deprivation in the current area doesn't depend on their income. Okay. And then moving on to these what we call these group means. So what we've done here then is calculated these individual and household specific effects, just as we did in the overall example. But now what we've done is we've done the averaging separately for each income quartile. And what we've got then are these the push effects for each income quartile. And there we can see that the push effect is increasing, of deprivation is increasing with income, both in the rest of England and in London, and overall in London the push effect is lower. So it looks from this side that we've got a reasonably strong effect of income on these on the push effect of deprivation. And the reason that we've got a difference in the sort of conclusion between these two sets of results is that here we're taking into account other characteristics other than income that decrease a person's sensitivity to deprivation. Okay, and they're sort of cancelling out, if you like, with characteristics that are increasing their sensitivity. Okay. So I think it's important to look at both of these results. Coefficients, because they're useful for thinking of the idea of looking at sort of net effects, controlling for other characteristics. But then this is looking at, if you like, typical effects, when you look at how these characteristics go together, how they're correlated. But these are derived from the coefficients. Okay, and now we move on to pull effects. So the minus 0.37, that was the main effect that we saw earlier, and now what we can see is that in both London, but particularly in London and the rest of England, we have a strengthening of the pull effect of deprivation with increase in income. Okay, so and particularly strong effect in London, so a well-off Londoner is more sensitive to deprivation when they're relocating than a well-off person living outside of London. That's the idea. And that difference between London and outside London in this income effect is significant. That's what this test of equality is here. Right, so there's a significant difference. Okay, I'll focus on the coefficients. The next one we talk about is tenure, household tenure at T-1. Now we do include in the model indicators of change in tenure, so these are the main effects. So these represent effects of tenure for those who remain in the same tenure between T-1 and T. Right. So what we see here then is that to look at private renters relative to homeowners, which are in the reference group, private renters actually have a negative push effect, because their effect would be 0.19 minus 0.56, which seems a bit counterintuitive. So higher deprivation in the current area is associated with a lower probability of moving out, and perhaps that's to do with affordability, okay, for renters. Similar sort of effect here for social renters, but stronger, and particularly so in London. Right. And again, I think that makes a lot of sense, and it's just picking up the idea at the beginning that what we're also observing here are constraints as much as preferences. Right. So there's a tendency for social renters to stay in deprived areas, or that they're less inclined or unable to move out of those. And when we then take into account this mix, that still shows up quite strongly, the difference between social renters and the rest, and we've got this push effect that's going in the opposite direction for the social renters. Okay. And then moving on to the pull effect of deprivation for tenure. Okay. Again, this is the overall pull effect. This is for owner-occupiers. So now for private renters, if you add that on to minus 0.37, we find really no effect of deprivation at all for private renters. But there is an effect in London. Okay. And what we're seeing there is that if we take the private renters and social renters together, is that this aversion to deprivation when choosing a new area is weaker than among owner-occupiers. Okay, and again, to do with affordability of rents for private renters, I would imagine, and also in constraints for social renters. No difference here between London and the rest of London. Okay, now we're getting short of time, so I think I'll just show you one more of these. And yes, okay, let's look at birth of a child. This is one of our transition indicators. And here I'm only showing you the coefficients, and I've got the push and pull effects shown alongside. So the reference group, that includes couples without children. So what we've got here, so the 0.28 and so on, these are the effects of a birth, if you like, the change in the push and pull effects following a birth. And in terms of push effects, there's no difference between London and the rest of England, but there is some difference between the pull effects. Okay, and I've just summarised what those coefficients tell us at the bottom. So outside London, a birth is associated with an increase in aversion to deprivation in the current area, but also a decrease in aversion to deprivation when choosing a new area. Okay, so perhaps in order, if a person wants to move after a new child, so to perhaps move to a larger house, they have to move to a deprived area in order to afford to do so. Whereas in London, it turns out there's no impact at all of a birth on push or pull effects. Okay, and just end then, just with some key findings then. And I've just shown you a few of the results. So here, this is a summary of all of them. So a complete roundup. So in terms of push effects, so we find that overall higher deprivation in a person's current neighbourhood is associated with a greater propensity to move out, as you might expect. Now, home ownership and expecting a child, they increase sensitivity to deprivation in the current area. Okay? Whereas being a social tenant or a single parent reduces it. Okay? Again, I think it's bringing out constraints rather than preferences. And then moving on to pull effects, again, overall, high deprivation reduces inflow to a new area. But the aversion to deprivation when you're choosing a new area is weaker for those with low incomes, renters, either private or social renters, families with adult children, and those who are already living in deprived areas. So if you're already living in a deprived area, as we expected, there is sort of less aversion to deprivation when choosing a new area to live. And we also find this aversion to deprivation is weaker among those who are expecting a child, but only outside London. Okay, I think Hill's been very good in not showing me the 5-minute card, but I'm sure I've got there. So I think this is a good place to stop anyway. And the random effects will have to wait. But I'd say I'll leave the slides if anybody's interested. Okay.